So this is the key to the Advanced Algebra Trig quiz 7.1 to 7.2. You guys wanted me to go over it, so I'm going over it now. So let me zoom in here. All right, so number one, let's go over these. All right, so sorry, I'm trying to use a new pin thing that I bought. All right, so rewrite the expression in rational exponent form. So equals, so cube root of 7 is going to be 7 to the 1/3 power, and that's it. Ah, sorry about that. Next one. This one is going to be your base is 5. All right, 10 is your exponent, so that's your numerator. 6 is your root, so 10 over 6. That does reduce, so that's going to be 5 to the 5/3. Keep in mind the top number is your how many fives you have. 5 fives. You need 3 to take out 1, so you can actually take out a 5. All right, so that's going to be 5 times 5 to the, let's see, take out 3, you get 2/3 left. So to the 2/3. And that's your answer there. Alrighty, next one. Oh, oopsie. Alright. So rewrite an expression in radical form. 1/3 power. The bottom 3 is your root, so it's a third root of 19 to the first power, but the first power doesn't really do anything, so that's it with that one. Next one, 6 to the 2/3 equals, so the bottom number is your root, so it's going to be a third root of 6 squared. Since 6 squared, that's not enough to take it out because you need 3 of them, so go ahead and just go multiply that out. So it's going to be third root of 36. That's that one. Okay, next one, evaluate without a calculator. So that just means it's going to show your work is all. So you're going to do the third root of 8 to the 4th. So you don't have to turn it into radical, but a lot of you guys do, so that's why I'm doing it this way. So do that. So you need 3, you have 4 8s, you can actually take an 8 out. And then you're going to have a cube root of just 8. So it's going to be 8, cube root of 8. So if you need to, you can make a factor tree. 8 is just a 2 times a 2 times a 2. So it's the cube root of 2 to the 3rd power. So you can take a 2 out. And 8 times 2 is a 16. Okay, use properties of exponents to simplify. So when you guys have the same base, which are the x's, so your x's are the same base, you take the exponents and add them together. So that's going to be x to the 2/3 plus 1/2. You need common denominators here, so that's going to be a 6. You can turn that into a 6 by multiplying by 2, so you're going to get a 4 over 6 plus 3 over 6, which is equal to 4 to the 7 over 6. Now you got 7. Oh, why did I put a 4? That's not a 4. Silly x turning into 4s. Okay, there you go. So x to the 7/6. So you have 7 x's. You need 6 of them to take one out. So you can take one of your x's out. So if you took 6 of them away from 7, you're going to get 1/6 left over. So it's x times x to the 1/6. And that's that one. Whoops. All right. Next one. Okay, 1/2 power. So you're going to put that 1/2 to the top and the bottom. So that will be x to the 1/2 power, which is like a square root, because remember the bottom part is your root. So you're going to do 16 to the 1/2 power, which is like the square root also of 16. X to the 1/2 can stay the same. 16 to the 1/2, so the square root of 16 is a 4. No bottom part to rationalize, so that is it for this one. Let's go to the next one. All right, so use properties of radicals to simplify. So since they are under the same roots, they're both cube roots, That means you can put them both under the cube root of 4 times 2, which is an 8. Reason why we're doing this is because 4 is just two 2's. That's not enough to bring one out because you need triples. So 8 breaks up into 3 times 2 to the third power. Since I do have the same powers here, you guys can cancel those out. Inverse operations, so they undo each other. And you get a 2 there. All right, so next one, same thing here. You should be on the lookout for same bases. If you have the same bases, you can put them together. That's going to be a third root of 250 divided by 2, which is the third root of 125. Oh, it's not a negative. There you go. Third root of 125, which is a 5. Okay, so that's B. Let's do number 6. Okay, fourth root of 96. So this one, a little bit of work here. It's kind of a bigger number than we're used to working in class. So you can do a factor tree here. So 3 times a 32. Okay, this makes it a little bit easier. That's going to be 8 times a 4. All right, so the 4 turns into a 2 and a 2. And the 8 makes 3 2's. 2, 2, 2. And keep in mind we're looking for 4 of a kinds. So 1, 2, 3, 4. So you can rewrite this as the fourth root of, we have the 3, so let's put the 3 back in, times 2 to the fourth, and then you got an extra 2 on the end over here. So times 2. So the reason why we wrote it like this, because now we have a fourth root and a fourth power, which are inverses of each other, so the 2 can come out. Fourth root of 3 times 2 is left over, so you have a 6, and that is it for that one. Next one. Third root of 12 over 25. 12 over 25 doesn't reduce, so we got to start working with this one. One way you can approach this, a lot of you guys are messing up with the fancy one thing I was teaching you, so I do want you doing this. So break it up into the third root of 12 over the third root of 25. Now, third root of 25, I'm going to write 5 as a 5 squared. Now we need 3 of them. We only have 2 of them, so we got to multiply by the fancy 1. All right, so that's going to be a cube root of, we need 1 more, so 5, and then a cube root of 5. Now, be careful here because you can't put them together unless they have the same root. So on the bottom, they have the same root, so you're going to get a cube root of 5 cubed. Now, on the top, it's the same also, so you can do 5 times 12 is 60. So cube root of 60. On the bottom, the 3's will end up undoing each other, so you get a 5 on the bottom. On the top, you get cube root of 60. That doesn't break up into any perfect cubes, though, so that's just going to be cube root of 60 on the top. All right. And let's go back over here. All right, so number 8, the root of 28 y to the 5th. So that's going to be, oops, the square root of, so you need perfect squares in here, so 2 squared, because that's 7 times 4, and 4 is a perfect square. Y to the 5th is not a perfect square, but it has one inside of it. That's y to the 4th times y to the 1st. Y to the 4th is a perfect square. Y to the 2nd is a perfect square also, so you can pull out a 2. You can pull out 2 y's, so y squared comes out. Square root of, so this came out and this came out, so you got a 7y left over. All right. Why is that doing that? There's marks there. Go away. All right. And by the way, technically I'm not talking to myself. Since you're watching this, I'm talking to you. So that takes care of my crazy plea. Okay, so this one we have a fourth root and 5th root. I showed you guys a shortcut in the class, so I'm just going to do it that way here. So 32 is going to be 2 to the, let's see here, 32 is going to be to the fifth. So you can rewrite this as 4 2 to the fifth power over fifth root of 2 to the 248 power. So third power, sorry. Um, so now that we have it like this, instead of doing the whole rationalizing the denominator thing, let's go ahead and turn it into um, rational exponents. So that's your numerator, that's your denominator. So you can get 5/4 on the top, and then 2 to the 3/5 on the bottom. Um, quotient rule, uh, quotient of powers rule means that we're going to subtract these. So you're going to get equals 2 to the 5/4 minus 3/5. You need common denominators there, so common denominator between 4 and 5 is a 20. So to make a 5 into a 20, multiply by 4. So it's going to be, I'm sorry, to make a 4 into a 20, you multiply it by 5. So you're going to get a 25 over 20 minus 12 over 20, which is equal to, so 25 minus 12 is a 13, so it's 2 to the 13 over 20. So we got 13 twos, we need 20 of them to take out, so you can't take anything out. You do not leave it in this form since our original form was radicals. So you're going to do the 20th root of 2 to the 13th power. All right, so next one. This one you actually have the same powers, so you're going to do the 512 over 8 all to the 1/3 power. Okay, so 512 divided by 8 is a 64 to the 1/3 power. So you're just thinking what times what times what is a 64, and that would be a 4. All right, almost done. 11. Okay, before the operation, write your answer in simplest form. So anytime you guys are adding or subtracting, and in this case we are subtracting, since we're subtracting, we need like terms. Right now, these are not like terms. So let's go ahead and break these apart. Since I know that I'm going to do some type of fourth root here and a fourth root here, this 8 has no chance of coming out because these are just 3 2s. I need 4 of them. I only got 3 of them. 648 is a pretty big number, so that should break up pretty nice. 8 times 1 is 81, 64. So it's going to be 81. All right, 8 just breaks up into a 2, 2, and 2. 81 is a 9 times a 9, which is basically 4 3s. Break the parts there. All right, so rewriting this, it would be, let's go ahead and put it in rational form, or radical form. Radical form. So we're going to do fourth root of, let's see, 2 to the 3rd, 3 to the 4th, minus 2 times fourth root of 2 to the 3rd. All right, so we need a fourth power, and we have a fourth power right there. So those two will cancel out. A 3 comes out. We already have a 5 on the outside, so now a 3 comes out also. This 2 to the 3rd can't come out because you need 4 of them. There's only 3 of them. So 2 to the 3rd stays in. 2 to the 3rd power is an 8. Okay, same thing with this one. You have 3 of them. You need 4 of them. So you can't take anything out. So that's just going to be a minus 2 fourth root of 8 also. So now I have like terms. Whoops, not that part. Okay, I have like terms here, 4 root 8, 4 root 8. But let's go ahead and multiply this 5 and 3. So 5 times 3 is 15. Fourth root of 8 minus 2, fourth root of 8. And you get a 13, fourth root of 8. Can't leave it like that though, because I do want you writing your final answers in the same form. So your form was rational exponent form, so it's going to be 13 times 8 to the 1/4 power. All right, next one. Perform the operation. So with this one, you have a power of products. So it needs to go to the products, both of them. These are first powers. It's a first power there. So 1/2 goes to both of those. They're not like terms yet, so you can't subtract. So you're going to get x 9 to the 1/2 power, y to the 1/2 power, minus 2 times 1/2 is 1. So x to the first, y to the 1/2 power. And now the 1/2 power of 9 is a 3. That's basically asking you guys the square root of 9. Square root of 9 is a 3. Write your x, write your y to the 1/2 minus x, y to the 1/2. So now you have like terms here and here. Those are like terms. So you got a 3 here, and remember there's a 1 there. So if I have 3 of these, and I take away one of the same thing, then you're going to have 2 of those. So 2xy to the 1/2. That's a cool circle. And last one. Okay, perform the operation, write your answer in simplest form. These are square roots. Remember, when it's asking for a square root, there is kind of like there's a 2 here. That's square root. Standard form means there's gonna be, you're looking for pairs basically. So you can rewrite it 27. I'm gonna put the 2 root just to be explicit about it. 27 is 9 times 3, so 3 is a perfect square. So 3 squared times 3 plus 2, perfect square, and there's a 4, which is a 2 squared times a 3. Now that you got your matching powers and exponent, roots and powers, you can take out a 3 here. That other 3 stays in. And this has the same root, same power, so you can take a 2 out. Second root of 3. We now have like terms again. We have 3 of these things plus 2 more of the same thing. That means you have 5 of the same thing. So it's going to be 2 root 3 again. And that is your quiz. All right. Hope this helps, and make sure you make those corrections. Bye-bye.